the topic of today's presentation is automation. I lead the network automation business unit at Nokia, and for those of you who are familiar with the products, our flagship product is Network Services Platform. We also have a virtual network orchestrator that helps orchestrate large deployments in SD-WAN and broader. And in today's presentation, we'll try to cover some of the needs and some of the ways in which NSP can help you, our customers, automate various parts of your network, various use cases. But before we start this, we thought we'd do something a little bit different, a little bit fun. We'll do a short demo. Now, this is a live demo on stage, so it's a little bit tricky. And I'll be inviting Moataz Soliman to stage to help me out with this. Moataz he's a lead for our product management for APIs, open interfaces, DevOps environments. So he's the guy you want to talk to when you are trying to integrate your applications or SSs into the network using NSP. Now, one thing you should be aware of is, first of all, Moataz suggested to do a live demo on stage, taking that risk, so that's requires a little bit of courage, so I appreciate that. Second one, this is the first time he's speaking in front of such a big audience, so I would like you to help me welcome him on stage and see the demo. So, welcome, Moataz.
Thank you.
Before we start, maybe you can just share with the audience what are they about to see, and why is this relevant for this session?
Of course. So we always listen to our customers, and two things have been coming up quite a lot are the concepts of programmability and automation, just as was mentioned in the Vodafone presentation before, right? So what we wanted to do is come up with a small demo that is fun, but at the same time, easy to understand on stage here to demo the concepts of programmability and automation using NSP APIs. So what we're going to be demoing is how you can use NSP APIs to drive your network and to consume your network.
Okay, but how are we going to do that?
So we're going to be doing that actually. As you can see here, it's a live demo. So I know everyone gives the advice to avoid live demos on stage, but we decided not to take that advice. So we'll see how this one goes. So I'm going to be using my phone for this. So as you can see, my phone is actually mirrored live on the stage here, and we can do things like, okay, Google, can you let me talk to my NSP assistant, please?
Sure, let's get the test version of NSP.
Hey Moataz, how can I help you today?
So as you can see here on the slide, we're assuming basically we're a large operator, and here you can see the service map of NSP. And we see a couple of sites. You see things like Athens, Amsterdam, Brussels, and we're assuming that we're managing this network. And I have a customer who's requesting a point-to-point service from Athens to Amsterdam with 100 megabytes per second of bandwidth.
Sure, I can help with that. What would you like to call your service?
Let's call it Destiny.
Thanks. Please confirm that you would like to deploy a point-to-point service called Destiny from Athens to Amsterdam with 100 megabits per second of bandwidth.
Yes, please go ahead.
Your service has been created. Anything else I can help you with?
So, as you can see here, our service actually has been created, and this is a live demo. So, Google Assistant basically used NSP APIs to deploy the service on the service map, and you can see this path. So this would be perfect in a normal scenario. But in the context of 5G, low latency, and faster networks, we need to check the latency for this path. Can you check the latency, please?
Of course. The latency of the service path is 105 milliseconds.
That's not good enough. This is a gaming service. So I would need the lowest latency path from Athens to Amsterdam.
The lowest latency path goes through Brussels with a latency value of 35 milliseconds.
So as you can see here, NSP controller can actually read the different latency values from the network. And if you measure the latency path from basically Athens going through Brussels to Amsterdam, it's going to be 35 milliseconds. Excellent. Can you please switch to this path instead?
Yes, of course. It's done.
So as you can see here now, the optimization call went through to optimize the service path to use the service via Brussels. And we can also see on the service map that our service has been updated to use the new path, as you can see here. Thanks.
Just before I go, I really enjoyed working with NSP, and I think everyone should use it as well. It's awesome.
Thank you.
So,
Thank you, Michael.
just one last thing. One last thing before I go. A couple of colleagues dared me yesterday to take a selfie with Sasha on stage. So I'm just going to do this very quick here.
Right.
Thanks, everyone.
Thank you. So clearly, the point of this demo is not to encourage you to write applications using Google Assistant or Alexa, which you might want to do. But the whole point is to really realize how simple and fast and efficient it can be to consume the network if you have the right infrastructure, if you have the right APIs. Right? And the programming of applications can be done by focusing on the application itself, not on integration into the network. And that is the whole fundamental principle on which we've been building management and control applications in these organizations for many, many years, openness and programmability. So we'll talk about this in this presentation in a little bit more detail. So first, earlier today, there was a number of comments about automation being a journey, and it really is a journey. Right? We've been evolving how we do things in a network for quite some time now. And at this point, we are at the stage where we are focusing a lot on automating repetitive tasks in various aspects of your organization. Sometimes some people are focusing on operational tasks, some people are focusing on assurance, some people are focusing on different kinds of maintenance activities, etc. It doesn't really matter. It's all about having the tools and capabilities to automate those repetitive tasks. The next stage is more focusing on sort of closed loop automation. Anything in the network that can trigger events and action in the network. And Rudy talked about this quite a bit. For many years now, we have been investing in all the different aspects of that closed loop to make sure that we can get the insight, that we can process the data and really arrive to some actionable insight, that we can push the actions into the network, that we can monitor, et cetera, et cetera. So there's a lot of activity in this space. And then finally, kind of ultimate goal effectively is to reach that kind of fully autonomous, self-driving network. But for that, you require a lot more technology advancements. You'll see some work we've been doing with machine learning and AI, but many other improvements are needed in the network. But more importantly, I think we also need to focus on challenges and understand the challenges that we are facing to get there. Right? It's not just about technology, it's about other things as well. And some of the challenges, it was interesting, Vodafone colleague Argyris spoke about this, is there's a lot of human challenges as well, not just technological challenges that we are facing. The road to this kind of automated networks is not straight line. It's a little bit of a curvy road. And we need to at least be cognizant of and aware of those challenges that we are facing. One is looking at the jobs, how jobs are changing and how skills are changing. We talk about technology, but we also need to recognize that as we introduce technologies rapidly into our organizations, both as vendors in our R&D organizations and as operators in your engineering teams, in your operations teams, we are asking engineers to learn new skills pretty much every single day now, right? It used to take decades, now it takes 6 months. When you look at technology adoption curves, they are rapidly accelerating. And with that, we need to create environments in which people can absorb all of that and apply in their daily jobs, which is not easy. The second aspect of it is I think it's even more fundamental, is soft skills and how we operate as organizations, how we build products. We talked about, earlier today was mentioned about agile development. Yeah, we moved our R&D organizations to agile organization 10 years ago. But what does that mean in terms of this collaboration, how we team, how we create things, how we communicate? There's a lot of different challenges in that aspect as well. So we need to be cognizant of it, of that as we develop towards automated world. What does it mean for the jobs, and what does it mean for how we approach the technology? The other aspect is the trust, whether we trust the automation. Right? I was talking to someone yesterday, and they said something like, this was kind of interesting. Oh, this is really complicated manual task, so we shouldn't be automating it because it's risky. Well, maybe we should be automating it because it's complicated and risky, right? But we as humans, we do have a tendency to not trust something we don't understand fully, and we also have a tendency to want to have a control over it. So in order to overcome that, for many years now, we've been making sure that in the product itself, we build in checks and controls that give a person who's driving a fully automated train, by the way, she's smiling, unlike the other guy who was shoveling coal into the steam engine, to give them visibility, real-time view of what's happening in the network, to give them controls such as, hey, I want to do something manually versus I want to switch something to fully automated. We also need to make sure that at any point in automation, at any stage, there is a control to pause and roll back. Because without that, we will not be automating things. Humans will not allow something to happen without any control. Right? That's a human nature. So we are taking that into consideration when we are building the product and when we are automating use cases. So when we look at the needs of all of you, there's hundreds of operators here, customers who come from different domains and different spaces. We find that there's fundamentally three kind of groups of the needs for automation. One group is, you can almost say, hey, I need a full solution. I need a full solution for various reasons. One might be I don't have a large team, or I don't have the skills. I don't want to be the systems integrator. I don't want to deploy heavy OSSs that integrate into a variety of different technologies. And for that, I need a partner that will bring the full solution with all the management and control set of applications. You can equate that to sort of buying a car. You know what your needs are. You know you need a sport utility vehicle, you need a station wagon, whatever it is. You walk into a dealership, you find the one that fits your needs, and you purchase a car. The second one would be the equivalent of needing to better control the traffic for various reasons. And we've seen that early in the presentations today as well. There is an increased need to better understand in real time what's happening in the network traffic-wise, and to better control it as well, because of either quality of experience that is at risk in some cases, or simply the cost of running those networks as the bandwidth demand increases. So in those cases, you really need a steering wheel. You need a set of controller tools in different use cases. We won't have time to cover them all, but we are obviously investing heavily in this space, and I'll mention some, but you'll see some in the demo as well. And then finally, we see the increased move and shift towards more and more need for programmable open platforms that allow you, operators or your partners, to develop things yourself, to take control into your own hands and build your own applications that fit your needs. And all you need from vendors like us are bits and pieces that you either don't want to develop, or you find it more scalable, more efficient to procure from us, or it's a combination of things. So in those cases, all you need is an engine, and you can build on top of that. Let's take a look at how NSP addresses those needs, and what are the things that we are worrying about. One is the engine. A lot of investment in this space. Rudy mentioned it earlier. He touched on workflow engine, but there's a ton of other development that we are doing in this space. And fundamentally, the purpose of this investment is to enable any kind of application to integrate into the network in a scalable, reliable way using open and programmable interfaces. That's what it is. And the network has to be not just Nokia network, it has to be a multi-vendor network, because more and more we see the efficiency comes from actually creating these domain orchestrators, domain controllers that cover the entire IPLS domain, IPMPLS domain, for example, rather than vendor silos. The second one is the set of applications that build on top of that. And those applications deal with typically traffic steering in some way, shape, or form, whether it's a stateful PC for segment routing, whether it's express peering use cases where we shift traffic on peering links, both in ingress and inbound and outbound traffic based on certain criteria, based on input from deep field, et cetera. Whether it's 5G slicing using NFIX, as you've seen earlier in Rudy's presentation demo there, NSP is playing a key role there. So there's a number of different optimization applications. And then finally, there is a whole set of applications and big investment we are making in fully integrated and automated provisioning, network and service provisioning applications, supervision and assurance applications, and so on and so forth. So we'll cover some of those as well. So let's start first with with those assurance applications. You can imagine you know there's configuration and provisioning apps that we can talk about. Zero touch provisioning has been big, and we've been investing in this space for quite some time. You can go and see the demos as well in the demo room. There's quite a few provisioning apps that we have. Service assurance and automatic assurance and investment in kind of closing the loop and improving the way we monitor and assure the networks is a big part of our investment. So this is what I wanted to touch on in this section. So let's take a look at this. So one aspect is knowing what is happening in the network right now. Right? And we've always kind of, in the past with 5620 SAM and with NSP, we've always took big pride in saying, hey, it's as real time as it possibly can get, because it was getting all the notifications, it was keeping state of the network and topology of the network, et cetera, et cetera. With the advancement of telemetry that Rudy talked about, it's getting even more so. We have information about every single aspect of the network in real time, and we've built applications that can show that on the screen to the user, whether it's a service supervision, whether it's a network supervision application, any kind of a dashboard, variety of them, immediately show the health state topology of the network in real time. Then there is a whole set of applications that deal with what happened in the past, and primarily focused around different kinds of reporting views, historical reporting, graphing, etc., indicating what has happened in the past. And those two things combined will help you troubleshoot and understand when something's happening in a network. Then there is also an aspect of what will happen in the future, and how can you prevent something from happening in the future. And there's a lot of investment there. We are using machine learning algorithms to get as close as possible to knowing what will happen, when the anomalies will occur, etc. And then steer traffic accordingly. That helps prevent the degradation of service. So with that, you kind of have a full set of applications that are used for troubleshooting, for prevention, and for root cause analysis across the entire domains. And there's, as I said, there's not enough time to cover them all, so I encourage you to go speak to the product managers, see all of these applications in demo. In every single one of them, there's been a tremendous investment and advancement since the last year. New views, new visualizations, new capabilities. So in the interest of time, I'll just show you one example here. And this is the example that we have done with Shaw in Canada. It's an operator operating in Canada, and what they have is a typical problem of a small operations team that is dealing with tens of thousands of events in the network a day. They really don't know how to handle that scale. Right? They can't. Humans cannot process it. So what we've done is working with them and using the incident advisor capability in NSP, which is a machine learning based application that helps you triage, understand events in a network, and really arrive to the action and resolution quickly. Right? That's the whole idea. So what we've done with them is looking at their network, processing the events, taking those roughly 30,000 events on average per day down to meaningful 10 situations or incidents per day. Roughly, that's the ratio using this application. And for them, it's a tremendous saving, because they're now looking at this as the main view into the network. Rather than looking at 30,000 alarms or what have you, they're looking at these 10 things as a starting point and then resolving those problems. So the way it's done, and you can see a demonstration in the demo room of this, is it starts with the telemetry, and taking the telemetry into the system from the network. And the important point here is, when we talk about the telemetry streams and looking at faults in a network or any incidents in a network, you will see a lot of products on the market that, for example, focus only on alarms, right? And doing root cause analysis, doing correlation of alarms, which is good. But the problem is they don't often convey the entire context or have all the information. Sometimes you have silent failures, sometimes you have things that happen without alarms being raised, etc. So what we found is that in order to get the real view of what is the health of the network or service, is we need to look at much broader set of data sets, right? It's alarms, yes, but also OM test results, configuration changes, route changes, state changes, stats, performance statistics, etc., and many other data sets. Processing all of that and using quite sophisticated algorithms without pre-written rules to arrive to those kind of clustered events. But before we get there, another important point is that in order to do that, understanding of the network topology and service topology is critical. It's not just any set of numbers and any random data that is being processed. It's also correlated with the network and topology awareness and configuration awareness as well. So with that, we process the events, we discard the noise, we cluster the events, sometimes even thousands of events into a single incident. We fingerprint that as something that can be compared to something else that happened in the past or in the future, and we start providing recommendations on what to do with it. So in the case of Shaw, their operators are using the system to provide recommendations. Oh yeah, I've seen this once, we did this, and then they start labeling the data. And after a while, what ends up happening is the system is now automatically recommending the resolution, and in their case, they're actually writing workflows to resolve some of the incidents that happen often in their network. They're all similar, they're never the same one, but the similarity algorithms are pretty good at determining that similarity. So what ends up happening is we take the operator out of the equation completely, and they end up automating the full closed loop using this example. So this is just one of the example of applications that I used in this kind of service and network assurance mode. So moving on to the next phase is to talk about the traffic steering. And in this case, there's a couple of examples I wanted to talk about. As I said, there's many different use cases for optimization in the network in general. The topic for today is an example of IP and optical coordination, right? Which is often a problem, because in many organizations that we see, those two teams are separate often. They run independently, and often that coordination or lack of coordination results in issues because of the lack of visibility or lack of understanding of one change in one layer impacting the other layer. So here's an example of Telefonica did a demo at Mobile World Congress this February, using NSP for their Movistar Play solution, where they're coordinating the information from the optical layer into the IP layer, and in order to really determine the degradation of the optical service and how it impacts the IP service, the video traffic on top. There's no actual failure, there's a degradation, gradual degradation happening in the optical layer. So in order to prevent that, so what they've shown is monitoring in the optical layer And that monitoring using Nokia WaveSuite applications, monitoring the performance of the optical link, and seeing gradual degradation. And you can see a short video here, which is showing that they recorded actually, showing the degradation going towards the red line. And then when it hits the red line, that's their arbitrarily set threshold, that triggers NSP to perform the basically reroute of the IP traffic away from that optical link. Now, that link hasn't failed yet, but it will because the degradation is slowly happening. So what NSP is doing here is, because it is aware of IP and optical layer at the same time, is able to move the traffic away, knowing where this optical failure will happen. So with that, and achieving that coordination sometimes can help with prevention of outages or degradation of traffic. The other example we have here is what you're seeing is a very short video of an NSP application called Cross-Domain Coordinator, where, again, you have, this is a physical layout, you have routers, a bunch of routers connected into the optical network, and you have a requirement for a lot of paths to be diverse. But you don't know whether they actually are, at this point in time, diverse. And when I say diverse, I mean not just in IP layer, but diverse across optical layer as well. So what we've built is an application to run the diversity analysis. So you can simply go and say, hey, I wanna check all the diversity in my network. There are paths, IP paths that have been grouped with this criteria. The system will run through all of them, compare their routes, and identify the ones that are failing the diversity constraints. So those that are failing the diversity constraints, the report will be generated. And when you see the report, you can see the details for each of the ones that failed. You can click on it and you can say, hey, this is why it failed. It failed because they're sharing an optical link at one part of the path. And if you go to the map and highlight them, you will visually see the highlight of those IP paths and where they're traversing the optical layer as well. And you will see that they're sharing a couple of optical links, which they shouldn't be. And that's the identification. A very simple tool that can help coordinate between the two layers in a much more efficient way. So moving on to the final part, and probably the most investment and advancements in the NSP in this area is all about open and programmable platform. As I said earlier, we focused a lot historically on open interfaces node-bound, and that investment continues. We always historically have been dealing with a plethora of different protocols, different kind of domains, different network elements, Nokia and otherwise. But that investment continues, especially with more and more advancements in netconf, YANG, and standardization of different protocols and object models. We have invested, and you will see this coming out this year. You can see a demonstration of intent-based networking, which we refer to as model-driven templating, and of course, workflow engine, which ties it all together and orchestrates a variety of different workflows within NSP. So let's go through it quickly one by one. First one is open APIs. I mentioned the investment in APIs, and it's been there for many years. One of the things that we talked about last year, we launched it last year, is our DevOps Portal. And as a developer, anybody who's done any kind of development knows one of the most important things is having the information about which APIs do I use? What are my reference implementations? Is there any sample code? Is there any how-to videos that can help me accelerate my development? All of that can be found on this DevOps Portal. There's a community access. There's access to tutorials, videos, SDKs, adapters for third-party integration. There's templates. Cloud Labs, which is super important. Often you want to do something, but you can't do it because you don't have access to the right software and right lab. So in this case, you go to this website, you click a button, and within an hour, you get a full network, IP optical network with NSP running that you can use for your own development and testing, etc. So those are all the things that are necessary for any kind of DevOps integration into the network using NSP. So you'll find a ton of information there. Since last year, tremendous success. Ton of users, almost 2,000 users, almost 1,000 organizations are using this. And mind you, these are not just our customers, these are also our partners. Sometimes even our competitors are using this portal in order to access the information about NSP and how to integrate into the network. The next one is the workflow engine. Now, workflow engine is critical for us because it is obvious that as much as we try to pre-package capabilities into NSP to help operators do what they need to do with as simply as and efficiently as possible, very often you find situations where there are customizations. There are some things that need to be changed just because the environment is slightly different in your case versus the typical case. And in those cases, what we want to try to do is avoid software upgrades, avoid back and forth between you as a customer saying, hey, I would like to make this change, and then we make a change, and 4 months later there's a new release, and then you need to upgrade, etc. That is the fundamental advantage of Workflow Engine. It can orchestrate any kind of tasks in a controlled fashion. So you have similar applications, by the way, on Microsoft platform or on Apple for flow or shortcuts respectively. Effectively, Workflow Manager does the same thing on NSP platform, right? So to give an example, here are some types of use cases that thus far our customers have been using Workflow Manager for or looking at using for. Typically things like any kind of repetitive tasks around activation, any kind of repetitive task about even housekeeping. You may want to periodically check your space on your compact flash on 1,000 nodes and do the cleanups. You may want to be pushing the pre-shared keys or certificates to the network. Many kind of types of repetitive operations that are very specific to your environment can be automated. Take an example of a software upgrade. Software upgrade consists of downloading the image, pushing the image to the router, and switching over and rebooting. But often there are pre-checks, there are post-checks, there are things that you need to do in your own environment that you want to automate, but cannot be done by us. Right? It has to be done with your knowledge of your operations and your procedures, right? So in that case, and doing that over hundreds or thousands of network elements is a tedious task. So in that case, automating those steps is really important. So this is something you can do with a Workflow Manager. You write the steps in a very easy to understand fashion. You execute them. You execute them in a controlled manner. You have the capabilities of proceeding or rolling back, etc. And then you have the visibility of everything that is happening in this process. And now tying workflows to other aspects of NSP is also really important. It's not just another scripting tool on the side. It's the scripting tool which also integrates into all the messaging information on NSP, and all the mediation capabilities of NSP, in all the other APIs that are available that you can rely on as the steps in your workflow. It's obviously scalable and reliable as the rest of NSP, and it's supported. And it's also supported not just from a support perspective, it's supported by our Nokia experts. Very often, a lot of our customers like this capability, but they don't have the skills to write these workflows. So they say, hey, can you help us? Come and write this workflow for us and make it work for our environment. And we do have the experts who can do that. So this is also an important aspect. So as I said, I encourage you to go and check it out. Intent-based networking. This is a big step towards taking some of the ownership of configuration and state from the network into the control layer. So fundamentally, what this capability in NSP allows you to do is to say, I want to define what the end state should be for these network elements or for these services. And I want to define it in a manner that is abstracted, that is vendor agnostic, that is even technology or topology agnostic. And I want to let the system figure out how to make sure that this state is implemented across the entire network. So in order to do that, you may want to say, hey, I want to have an E-line with this gold profile, and I want to translate that abstract into specific. And that specific configurations may need to take into consideration network topology, vendors, releases, all the details about that, right? So in order to do that, you need a set of templates that you can define. You need a set of business logic that you implement, and then you run the whole thing through the transactional mechanism. So let me show you how it works. So there's templates. Some templates are predefined. Some templates can be built by yourselves. Business logic can be implemented again by yourself or Nokia experts. But characteristics are the following. Business logic execution is transactional. You can say, hey, I want to run this, and if I run into a failure, I want to roll back. Or, so this is that example. Or I could decide to actually proceed. Maybe you're pushing some configuration into 1,000 network elements, and 20 of them are not reachable. So you decide to proceed, and then you will finish later on. Or even more important, for those 20 that have failed, there is an audit happening all the time. And as it happens, it will determine that there is a misalignment between desired intent and what is configured on the network, and it can trigger redeployment of that configuration again. So fundamentally, this tool, combined with the workflow engine, is really meant to allow network engineers take control over what's happening in a network, automate things in a network, and abstract the interfaces and integrations into the IT systems, into the API applications or OSS products in such a way that there's no dependency between the two. And obviously, with that, accelerate the changes in a network without creating that dependency. So one last example, mediation towards the network. Here's an example with Bell Canada. It was mentioned earlier, Sri talked about this, investment in a multi-vendor environments. We're seeing it all over the world. Multi-vendor is becoming a norm. The efficient way of managing the network is by creating the controllers that can cover multiple vendors. And in Bell Canada example, they had a challenge. They had NSP managing a Nokia part, and then they had CLI managing Juniper boxes. And the simplest thing that they needed to do was extend the NSP capabilities to cover Juniper and other boxes. And with that helped them not only operationally save and simplify their operations, but also remove the pieces of software that they've built custom just to bridge those vendor silos. So with that, using NSP, they get simpler operations. They get single service fulfillment API and the GUI that they're using now across multiple vendors. And obviously, tremendous time savings. So really, hopefully this presentation has helped kind of illustrate all the areas of investment, and all of them with the goal of automating various aspects of your networks, making it faster, easier, and more efficient for you to run your networks. As I said many times, there's tons of great demos. I encourage you to go see them. Go speak to the product managers. There's many experts here that can give you great detailed information about all of these different aspects of NSP. And I hope you have a tremendous rest of the event. Thank you.